Hello, and thanks for clicking on this Narge 1 production. Today, we're going to talk about geometric sequences. We've already talked about arithmetic sequences, so now we're going to see how they differ from these geometric sequences that we're about to talk about today. Okay, so let's get started. All right, so here's the problems that I asked you to complete. If you take a look, here are your answers, okay, as well as the patterns that I used to get each of the remaining values. So you can take a look at those, make sure you have them correct. Okay. And then if we look down at the couple of questions down here, it wants to know which of the following patterns are arithmetic sequences. So arithmetic sequences, we recall from the other day, they have a common difference. Right? And a common difference means you add or subtract the same value to get to each term. Okay, so which ones are adding and subtracting to get from the next term? Letter A, you're adding 4, and letter E, you're adding 7. So those are both arithmetic. Now, let's look at the ones that are not arithmetic, because those are the ones that are obviously interesting to us today. What do you do to get from one term to the next? Well, if you look, okay, in letter C and D, you're multiplying by 3 each time. And then in letter B and F, you're dividing by 2. But there's something that I need you to understand about division. So you need to remember that dividing by 2 is really the same thing as multiplying by 1/2, multiplying by its reciprocal. Okay, 16 times 1/2 would be 8. Half of 8 would be 4. Half of 4 would be 2. Half of 2 would be 1. So instead of saying dividing by 2, I could also say that I'm multiplying by 1/2. And that's really important for geometric sequences. So the sequences that are not arithmetic, what are we doing to get from one term to the next? We are multiplying by the same value. Okay, we are multiplying by the same value. That's what we're doing to get from one term to the next. Now again, I understand that you may have done this by dividing by 2, and that's okay. But you have to understand that dividing by 2 is the same as multiplying by 1/2. Okay, because what we'll see on the next slide is when we try to talk about geometric sequences, we talk about multiplication, not division. All right. Okay, so let's continue on. And now, here we're going to talk about geometric sequences. So many sequences don't follow a pattern that have a common difference, but has a pattern that follows a common ratio. So now we're not talking about common differences anymore. We're talking about this thing called a common ratio. A common ratio, or R, is a number that is multiplied to find each additional term of a sequence. Okay, very, very important. It is multiplied. Notice I did not mention it's divided. It's only multiplied. So what does that mean for me? That means that if I have a sequence where I am multiplying by 3, then I know R is equal to 3. That'll be my common ratio. If I have a sequence that I'm multiplying by 5, then R will be 5. If I have a sequence that I'm multiplying by 6, then R will be 6. But if I have a sequence where I'm dividing by 2, I can't say R is equal to 2. Dividing by 2 means I'm multiplying by 1/2. So I have to say R is 1/2. If I have a sequence where I'm dividing by 7, I can't say R is 7. I have to say I'm multiplying by 1/7, the reciprocal. So R would be 1/7. Okay, so you can see why this idea that division is the reciprocal of multiplication is extremely important. Okay, is the same as multiplying by its reciprocal. Extremely important because you can only write down the common ratio as a number that's multiplied. All right, so here is also a hint to find the common ratio. Okay, to find the common ratio, you can divide the next term by the previous term. All right, we're going to see that in just a moment. Okay, so you're able to do that, and that will help you to get the common ratio. All right, so let's talk about these common ratios given these sequences. Here's a sequence. I'm going from 3 to 6 to 12 to 24. So I'm obviously multiplying by 2 each time. That makes my common ratio 2. And if I want to find A7, I'd have to multiply a couple more times. So I'd have 48, 96, and 192. So A7 is 192. I just keep multiplying by 2 to get there. In letter B, before we go to letter B, let me show you the hint or the trick. Okay? To find the common ratio, if you don't know it, you can't figure it out. Just take the term after and divide the one before. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 would be 2. There you go. There's your common ratio. It's 2. That's how we're doing it each time. Okay, in letter B, if you look, how are we getting from one term to the next? Well, you might say, oh, well, I'm dividing by 5. And you would be correct. That is true. You are dividing by 5. But when we're talking about that common ratio, it's got to be a number that's multiplied. So we can't say divide by 5. We can't say R is 5. We have to say you're multiplying by 1 over 5. That makes R 1/5. Okay, so again, if you didn't know that, you could divide. Take 100 and divide by 500. You would get 1 over 5, okay, or 0.2. Take 20, divide by 100. You would get 1 over 5, or 0.2. So that's your common ratio, 1/5. A5, I'd have to keep multiplying by 1/5, or dividing by 5. It's the same thing. I would get 4, and then I'd get 4 over 5. So A5 is 4/5. Okay, if I wanted the 12th term of a sequence, is there a faster way to do it than just by multiplying the common ratio 12 times? Well, I mean, that's in essence what you're doing, right? If you look at letter A, we started with 3, and then to get the next term, we multiplied by 2. That gave me 6. Then we multiplied that by 2. That gave me 12. We multiplied that by 2. That gave me 24. We multiplied that by 2. That gave me 48. Okay, we can go like this forever. But continuous multiplying by the same number is really an exponent, right? We can write this, for example, as this would be 2 to the 4th power, right? So I'm multiplying by 2 4 times here, and I'm multiplying by that 3. So we're going to have exponents in our new equation for a geometric sequence, because you're multiplying by the same number over and over and over again. And in math, rather than multiplying by the same number over and over and over again, we can write that number to the power however many times we want to multiply it. Okay, and that's what we're going to see on the next slide. All right, so the rule for a geometric sequence is n equals a1 times r to the n minus 1 power. Okay, so we already have an idea of what all this stuff is. We did this all pretty much already when we did the arithmetic sequence, although the formula was different. That was your formula for arithmetic sequences. All right, an is the nth term. That's the one you want to find. A1 is the first term. R is that common ratio. And n is the term number you want to find. Okay, that's your formula that we're going to use for a geometric sequence. All right, so it's very similar to an arithmetic sequence, but I guess it's a little bit different because, well, it is a little bit different because you're multiplying now, you're not adding. All right, so let's take a look at some examples. Okay, so I'm going to do 3 of these here, and then Maybe you guys want to try a couple as well. We're going to decide if each sequence is arithmetic or geometric. We're going to write its formula, and then we're going to find one of the terms. So for a geometric sequence, an is a1 times r to the n minus 1 power. For an arithmetic sequence, an would be a1 plus n minus 1 times d. All right, so in number 1, what are we doing? We are dividing by 2. But again, I can't say divide by 2. I have to say multiply by 1/2. Okay, so that makes this geometric. So r will be 1/2. A1 is 8. So my formula is going to be an equals 8 times 1/2 to the n minus 1 power. Okay, I'm using my formula up here. And I'm just plugging in a1, and I'm plugging in r. To find a8, I'd have to do 8 times 1/2 to the 8 minus 1. So 8 times 1/2 to the 7th, which will give me 0.0625 if I type it in the calculator. Okay, there's your answer to the first one. For the second one, let's see what we're doing. 21, 12, and 3. We are subtracting 9 each time. That makes this arithmetic. A1 is 21. D is -9. Okay, so my formula, here's my formula. Here's A. Arithmetic, an will be 21 plus n minus 1 times -9. And now to find a6, I'm going to put 6 in for n times -9. That's going to be 21 plus 5 times -9. So that's 21 minus 45, which will be -24. Okay, there is my formula, or there is a6, -24. All right, let's go to the third one. We have -5, -25, and -125. So what are we doing this time? We are multiplying by 5. Multiplying means it's geometric. So a1 is -5. R, common ratio for geometric, is 5. Again, if I didn't know that, I could divide. -25 divided by -5 gives me 5. -125 divided by -25 would also give me 5. So my common ratio must be 5. My formula, I'm going to follow the geometric formula this time. An is equal to a1, which is -5, times r, which is 5, to the n minus 1 power. Then to find a5, I'm going to put 5 in for n. Whoops. So we got -5 times 5 to the 5 minus 1. So that's -5 times 5 to the 4th power, which is going to be -3125. Okay? All right. You're going to have to go over to part 2 to finish up.